Hello everyone, my name is Zawal Parmar and I'm a data scientist. Today I will going to talk about how you can run the Retrieval Augmented Generation or RAG pipeline locally with Milvus Standalone. To start with, let me talk a bit about what is RAG and how it works. Recently these powerful large language models are getting really popular because of its utility in various different tasks. People are also exploring these models in various domains, and it is also performing quite well. But sometimes it also get challenging for large language model to get accurate answers when the query is related to the personal database or the corporate related database. Because it's trained on quite general data, it might not be able to answer specific questions. We can also fine tune these models on our own personal data, but still there are chances of hallucination and it might not be able to answer that accurately. People has also explored various prompting techniques. One of them is like providing the query related context along with the query as an input to the large language model, so that using that context model can accurately answer the query. So, but in production setting, how we can get the query related context automatically? So solution for that is rake. So here is the workflow for that. What we can do is like we can collect all the uh, personal or corporate related documents. We can use some model to convert it into the embedding, some n dimension embeddings, and we can create a vector database of all the documents. Now, when we get the query, we can use the same model to convert it into the n-dimension vector, and we can use that vector to search the relevant document from this vector database. We can use L2 distance or cosine similarity to compare the query embedding along with all the documents embedding from the vector database and can extract the relevant documents from that. Now we can combine our query text along with extracted documents and can provide it as an input to the large language model, so that it can LLM can use the extracted document as a context, can answer the query more accurately. Uh, so yeah, this is the basic idea about the RAG, and now I will go ahead with a demo. If you don't like to go through the whole video and like to read the blog, then you can also go through that. I have provided the link for that blog into the description. If you just want to look at the code, then you can also go to the repository of this particular project. I have provided link for that also in the description. For demo purpose, I have created a custom dataset of 5 products. I have used ChatGPT to create the respective description for all the products, and it has done really good job. So the first product is smart refrigerator, and the description includes its overview, key feature, related specifications, what you will get into the box, manufacturer related information, and its price. The second product is non-stick pen, and its description also includes the related information. I have selected 5 such products and created the description for that. To create the embedding, here I'm using a spacey model to get the embeddings from the text. So here I'm reading all the 5 text file, and one by one I'm converting that into the embedding, and creating a dictionary that include the text and also the respective vector, and dumping it into the JSON. So here the given model actually generates the 300 dimension vector, but for my purpose I have clipped it to 128 to speed up the computing. Either you can use all the 300 dimension vector, or to reduce the dimensionality you can also use other techniques like PCA or the LDA. So the final JSON looks like this, where each element has 2 key. One is vector, storing the embedding, and the text, having the raw text. Okay, now let me go to the RAG pipeline notebook. Here I also created the requirements file where you can see all the packages I'm using and respective versions, so that you can use that. In the Notebook, in the first cell I'm importing various packages and functions from it that I was going to use throughout the notebook. As you can see, like, I'm using Milvus for my vector database. So let me start with how you can install Milvus. So I have provided a link to this page in the description. You can either follow it to install the Milvus Standalone with Docker Compose. As you can see, you need to download this given YAML file either using command or download link. You need to save it as docker-compose.yaml file. You need to run this docker compose command from the same directory where you have stored the YAML file. It will going to start these three different Docker containers. As you can see, I have already run that process, and my three containers are running right now. Okay, let me get back to the notebook. In the next cell, I am defining various schema to create the table in the Milvus vector database. Here in my table, I want three different columns, that is ID, text, and respective vector. So I have defined three field schemas in which I'm providing the respective name and data type of that column. For ID, I have also set that as a primary key. I have also set auto ID equals to true, so as soon as new data will be entered, it will automatically generate new ID. For text, I have also provided maximum length and also a default value. So whenever there will not be any input, then it will set that as unknown. For vector field, I have also provided the dimension equals to 128. To define my collection schema, I have provided all the fields to consider. In my case, it's ID, text, and vector. And I have also enabled the dynamic fields. So uh, uh, in future, we can dynamically add new fields as well to given collection. I have also defined the variable to represent the collection name. In next cell, I am trying to connect with Milvus server that is running the local host at port 19530. In the next cell, I am creating the collection using collection name schema that we just defined. I also said using parameters to default, but you can also provide some other Milvus server where you want to create the collection. Here sard number is set to 2, that is the default value. You can also change it. It is representing number of data nodes it want to use while storing the data. So that many nodes will parallelly try to store the data. Okay, next I'm creating index into the collection. So initially I have defined the index parameter I want to use. The first one is metric type. So I want to use L2 distance while comparing various embedding into the vector database. You can also use cosine similarity or Manhattan distance or other metrics. The second thing is index type. I have used IPS underscore flat. So that is going to divide the whole dataset into the partitions or cluster, and that helps in speeding up the searching process. The next thing is parameters, where I have defined n list equals to 2. So it will going to divide the data point into two number of clusters. You can set it based on your data set, but there is a trade-off. As we increase the number of cluster, it will going to improve the searching process speed, but it might also affect the accuracy. But if we will keep the number of clusters to really low, then it will improve the accuracy, but it will also make the searching process really slow. The next thing is I'm creating the index using the index parameter I have just defined, and also I'm providing the field that is required to use to create the indexes. In my case, the vector column is having all the embeddings, so I have provided that name. You can use this utility function to observe the progress of building the index. In the next cell, I'm using the load function. So this function will allocate space into the disk so that I can store the data into. You can also use this utility function to observe the progress of loading. Next thing is now I need to store my data into the collection. So I am reading the product underscore data.json file that I just created. Then I'm converting into the data frame, which is list of data and vector. and providing it as a input using dot insert function. So it is going to create the indexes for different data points and store into the clusters. The next cell is to observe all the collections present in my Milvus server. You can use that to list out all the collections. Okay, so before going to the inference, there is also one more tool that is called A2, which is a graphical user interface for the Milvus. Let me also talk about how you can install it. So I have provided link to this page into the description. You just need to run this single command to start the auto. Here you are required to provide you are required to change these two things, your machine IP. So you can run the ip config command into your terminal. Just go to the wireless LAN adapter Wi-Fi section and take the IPv4 address and paste it here and just run this command. It will automatically start Docker auto. As you can see in my Docker, the A2 container is also running along with uh, all the four, all the three other Windows containers. Let me show you the A2. Right, so this is the graphical user interface for the A2. Here you can go to the dashboard where you can see all the collections uh, you have created. In my case, I have created multiple collections, but the product one is the one that we are using right now. Let me go into that. As you can see here, there are three fields: ID, text, and vector. Its data types are mentioned, also the index type and the metric it is going to use, and so on. So this is really helpful if you would directly want to create collection using graphical user interface. You can also use the add collection command here, where you can define the various schemas. You can also generate the indexes after this and also load the collection. So you can do the same process that we have done using Notebook, but using graphical user interface. So if you are comfortable with that, you can try to use Auto as well. Okay, now let me get back to the Notebook. In the inference section, in the first cell, I am loading all the models required and connecting to the Milvus server. For LLM response, I am using the Llama 2 7 billion shade version. I have used 2 bits quantized version of the model so that I can run it on CPU and also in my local PC. In the next section, I am running a loop where it will iteratively get the user query. When there is query is exit, then it will just break the loop. So just after taking the user input, it will use the spatial model to convert it into a vector and flip it to 128 dimension. The next step, I have defined various search parameters. One of them is like metrics I want to use to compare the query embeddings with the database embeddings. The next thing is offset, which I have set to 0. That is the number of entities I want to skip during the search, but I don't want to skip any entities, so I have set it to 0. Next thing is, do I want to ignore the growing segment? But I have set it to false. So it is actually represent whether you want to ignore the growing segments during a similarity search or not. You can read more about this in documentation. The next thing is parameters. I have defined nprob equals to 1. That is number of nearest cluster you want to search to find the similar document. I have set it to 1 here, as I have only 2 clusters and I want to just search within the more similar one cluster. In the next part, I'm getting the collection and doing search within that collection. I have provided the data, the query vector that I want to search based on, the fields that I need to search based on, that is vector having all the embeddings of data points. The search parameters I have provided, that I have just defined. If I will not provide the search parameters, then it will going to use index parameters that we have defined before. I have set limit equals to one, that is number of data points I want to return. I just want to return more similar text here, so I have set it to one. Then uh, which field I want to return for more similar data points. So in my case, I want to return only the text. I don't want the embedding, so I have provided text field here. The next step, based on the results, I'm extracting the distance between query and expected text, and also the raw text. Then I use that extracted text along with the user input, that's query, and created a prompt. I'm providing that prompt as an input to the LLM and getting the response. Um, Generally, it takes some time to run this model. So here I have already run a query, and I can show you the output. As you can see, the user input that I provided was what is the capacity and price of Frostbite Pro 3000 smart refrigerator. So as you can see, out of all the five products, it is able to extract the relevant document that is related to the smart refrigerator. It has also provided the distance of this document from the query I provided. And here is the LLM response. That is, the capacity of the first price for 3000 is 25 cubic feet, uh, while its price is $2,499.99. So as you can see in the documentation, the answer is exactly correct. So such a queries which are quite related to our own products or our own database, um, directly using LLM can't help, but using the RAG system to extract the relevant context and providing query along with these kind of context can help to get the relevant answer accurately. So that's all from my side on RAG. Let me know if you have any queries or confusion. I will try to help you with that. Thank you.